Hello and welcome to this maths training video. In this video we're going to have a look at the subject of fractions. This is part 5 in an ongoing series, and in this part we're going to look at how to switch between mixed and improper fractions. Now, we learned how to do this in the previous video. We learned what mixed and improper fractions were and what they represent, but what we're going to do in this video is just have a go at kind of drilling those skills down into our brains to make sure that we can do them quickly and without any hesitation. If you're super confident on this subject, then please move on to the next video in the series. But if you think that you need a little bit of practice, then this video is the one that's going to help you. So what I suggest you do is, as each question comes up, pause it, have a go at switching into the other type of fraction that you requested to, and then unpause the video and see if you've got it right. And that way you should make pretty quick progress. So without further ado, let's get stuck in and look at how we switch between mixed and improper fractions, give ourselves a refresher on how to do that. So the very first one that we're going to look at is this one here. So here we've got a mixed fraction. So we've got a whole number and a fraction, 3 2/3, and we want to be able to switch that into an improper fraction. So what this will be equal to as an improper fraction is what we're trying to get to. So a couple of things to remember to make your life really easy when you're doing this kind of question. Just put a long line over that side because we're going to be doing a little bit of maths on the top of this line, and then whatever number you've got over here on the left hand side at the bottom of the fraction, that just comes over and ends up going over here at the bottom of the fraction on this side. So we're going to be looking at this is going to be in thirds most likely, and we're probably not going to be able to cancel that down at all. And then what we've got to do is remember that this number here represents the number of whole ones that we've got. So we've got 3 whole ones and 2/3, representing whatever we want it to at this stage. Really, the question might be more specific, but in this case we've got 3 whole ones of something and then 2/3 of a whole one. So now what we do is we take this 3 here, and this one goes onto this side. So we've got 3 whole ones, and we want to think, well, how many thirds are there in that whole, in those 3 whole ones? So we do this 3 here now comes over to here, so we've got 3 times 3. So what we're basically saying is, how many thirds are there in this whole one? And we'll find out what the answer to that is in a minute. And then what we're going to do, so that's like a little calculation that we're going to do in its own right, and then we're going to add on to that whatever number we've got here. Now that might look quite complicated to start with, and it kind of seems like we've made this more complicated than it was before, but all we've got to do now is just do the calculation on the top line. So we've got 3 times 3, that gives us 9, and then we've got plus 2 over 3, and of course 9 plus 2 is going to give us 11 over 3, and that is actually the answer. So we've got 11 thirds. So can you see what we've done there? We've got this one broken up into thirds, so in each one of those there are 3 thirds. So we've got 3 lots of 3/3, which gives us this 9 over here, and then we're adding on this 2 here. So we've got 3 times 3 plus 2, which gives us 9 plus 2, which gives us 11 over 3. So that's 11 thirds that we've got there for our first question. Okay, so what we're going to do in the next question is we're going to roll on, and we're going to have a look this time at going the other way. So here we've got an improper fraction, and we want to know what the mixed fraction is going to be. So at this point we're just going to look at this and go, okay, so if we remember from a previous video, a fraction is just a division. So what we've got here is 12 divided by 5. We're saying how many 5s are there in 12? And it's really just as simple as that. We're just going to do a division. Now what we're going to do is we're going to say how many 5s are there in 12? So how many 5s are there in 12? You may recognise this as the bus stop method. It's a bit of a weird one because you're going to go, how many 5s are there in 1? Well, there's 0 with 1 remainder. And then we're going to say how many 5s are there in 12? Now at this point you're sort of thinking, well, what was the point in doing this? But all will become clear. How many 5s are there in 12? Well, there's 2, isn't there? Because we've got 5, 10, and then the next number takes us to 15, which is beyond that. And then you may remember this old trick from school. You then go, well, how many have I got left over? 1, 2. So we've got 2 with a remainder of 2. Now, what that does is actually that tells us what our mixed fraction is. We've got 2 whole ones with a remainder of 2, and then all we've got to do is move this 5 from here over to here, and there's your answer. So 12 fifths as an improper fraction is the same as 2 2/5, as a mixed fraction. It really is that simple. We'll have a look at a few more examples as we go on with this video. So hopefully you're doing okay with these. Let's have a go at another mixed fraction into an improper fraction and see how you get on with that. So you can see that we've got 4 5/8. That is our mixed fraction, and we want to know what that is as an improper fraction. So again, pause the video, see if you can figure out what the answer to this is going to be. Just follow those simple steps. We're going to say, put a line here, and we're going to move this 8 over to here. So we've got, the answer will start off in 8ths, certainly. We may be able to simplify it, we'll have to see. So let's have a look at this now. Remember, this is the whole number, so we've got 4 whole ones, and how many 8ths are there in 4 whole ones? Well, to find that, we just do 4 times by 8, and that will give us the total number of 8ths that there are in 4 whole ones, and then we add on those 5/8 there. That just comes over to this side, and then we're going to do that calculation. So 4 times 8 is 32 plus 5, and again we're over 8, and then the answer to this will be 32 plus 5, which gives us 37/8. Now, because 37 has no common factors with 8, so we can't cancel this down any further, so that's our answer, 37 divided by 8. So again, all we've done, brought this number over to the bottom, figured out how many of this fraction there are in 4 whole ones, 4 times 8 to give us the total number of 8ths that there are in 4 whole ones, and then we've just added on this chunk here. Now again, this may be helpful if you remember back to the previous video, always to try and think in terms of pizza. So it's like we've got 4 whole pizzas split into 8ths, and then we've got 5/8 of a pizza. So all together, we've got 37/8 of pizza to share out between however many people we've got eating our food. Always think in pizza when it comes to fractions, it's super helpful. Again, another example, how to go from the other direction, an improper fraction, to a mixed fraction. So we're going from this side on the right here to the side on the left there. So we've got 21/6. So again, we're just going to say how many 6s are there in 21? That one's gone off at a bit of a jaunty angle, but I'm sure you'll forgive me. So how many 6s are there in 2? Well, there's none, are there? So we're going to say 0 with a remainder of 2. How many 6s are there in 21? 6, 12, 18 gives us 3. With how many left over? What remainder have we got? So we've got 6, 12, 18, and then we go 19, 20, 21, which gives us a remainder of 3. So we've got 3 remainder 3. So again, we've got 3 whole ones, and then we've got a remainder of 3, and then the fraction that we're looking at here is this one here, which is 3 3/6. Now looking at this one, you may look at that and realise, well, 3/6, that's the same as a half. So you would simplify that down to 3 1/2, like that. And there we go, that's our mixed fraction converted from our improper fraction. Okay, and moving on, we're going to have a look at a mixed fraction there into an improper fraction. So let's have a look at this one. A little bit of a bigger number here, but exactly the same principle that we've looked at so far. Put the line in for the fraction. This 10 comes over and stays on the bottom, so we've got the answer will most likely be in tenths. And then we're going to say, well, how many tenths are there in 2 whole ones? Hopefully you're way ahead of me now and you can see that that is going to be a pretty obvious answer. And then we're just going to add on the rest of the tenths there, 7 tenths. So we've got 20 plus 7 divided by 10. So 2 times 10 gives us 20, and 20 plus 7 gives us 27 tenths. No cancelling down available there. So the final answer is 27 tenths is what we've got there. So again, imagine it in pizza. You've got 2 whole pizzas split into tenths. So that gives you 20 slices of pizza, plus another 7 slices of pizza, 7 tenths of pizza. Add them together and you've got 27 tenths of pizza altogether. And finally, one more example on the improper fraction, 17 fourths or 17 quarters, and we're going to find out what that is as a mixed fraction. So what is 17 over 4 as a mixed fraction? Let's figure it out. So once again, we're going to say how many 4s are there in 17? Well, 4s into 1 go 0 with 1 left over. How many 4s are there in 17? 4, 8, 12, 16. Gives us 4 with a remainder of 16 to 17 gives us 1. 4 remainder 1. So you can see that we've got 4 whole ones and then we've got 1 quarter left over. So we've moved that 4 from there to there. We've got 17 divided by 4 gives us 4 whole ones with a remainder of 1. So hopefully this, coupled with the previous video, has now given you an understanding of how mixed fractions and improper fractions relate to each other. And we can see it's fairly simple to convert between one and the other from the examples that we've seen there. So that concludes this video. Please make sure you've got this technique comfortably in your brain. This kind of question may come up in your exam. And of course, it's important, as always, if we're going to be electricians or engineers, that we really do want to understand maths as well as we can and be as good at it as we can, because I'm sure you're starting to realise that to be an electrician is to do a lot of maths, especially if you're looking at doing the design side of things. So we'll have a look at our following subject. We're going to continue with fractions in the next few videos. We've got some other bits and bobs to cover on this, and we'll continue to develop this theme. But all that remains in this video is to say thank you very much for watching.